Welcome back to the deep dive. Today we're heading into some pretty high stakes territory. We're
Yeah.
focusing on aerospace and defense, specifically how extended reality, XR, that mix of augmented and virtual reality is really changing the game for getting workforces ready in these critical fields. Our mission today for you listening is to really pull out the key insights from the sources we've looked at detailing EON Reality's new XR Library premium segment for aerospace and defense training. This isn't just like VR games, it's about using really advanced stuff, spatial AI, to lock down things like combat readiness and flight safety.
And it's critical we start with a why, because honestly, the sector is facing this double whammy of a crisis. On one hand, the consequences of failure are just astronomical. We're talking massive costs, potential danger to life. Think about an aircraft on ground event, an AOG, that downtime. Easily $150,000, sometimes up to $2 million
A day. Wow.
per day.
Mhm.
And in defense and space, you need zero error systems, period. There's no room for mistakes. But then there's the other side. The talent crisis. It's a huge brain drain. Our sources are showing about 1 in 3 skilled technicians, engineers, they're nearing retirement age.
1 in 3, that's significant.
It's huge. And the risk is losing all that built-up knowledge, that tacit expertise that isn't written down anywhere. It just walks out the door.
Okay, so that paints a clear picture. Extremely high stakes, incredibly complex systems, and the people who know those systems are leaving. Traditional training methods.
Yep.
They just can't bridge that gap, can they?
Exactly. You can't just take a $50 million jet engine offline for a rookie to practice on. It's way too expensive.
Or simulate some catastrophic space event. Just impossible.
Impossible.
Right. So this is where XR comes in. It offers these risk-free, immersive training grounds using something called Spatial AI. Now, before we get into the specifics, what is Spatial AI? How's it different from just a really good flight simulator, for instance?
That's a great question, because the difference is crucial. Spatial AI isn't just showing you a picture. It understands the space and the objects within it. It knows the geometry, the physics, how components connect and interact. So when a trainee is, say, diagnosing an engine fault in XR,
Okay.
the AI is tracking their precise movements. Did they use the right tool? The correct torque setting? Did they follow the safety procedure exactly? It's about enforcing that real-world precision.
Ah, I see. So it provides intelligent feedback based on physical understanding, not just pre-programmed steps.
Precisely. It catches errors that would be, frankly, disastrous on a live piece of equipment.
That makes sense. That level of precision is non-negotiable. Okay, let's unpack the first big area this impacts: maintenance, repair, and overhaul, MRO. That seems fundamental.
It really is the backbone for aircraft readiness, combat readiness. MRO excellence is critical. XR tackles this using these incredibly detailed digital twins.
Digital twins, we hear that term a lot. What does it mean in this context?
Think of it as a functional virtual copy of the real thing. Not just a 3D model, but a replica that behaves like the real system. An engine, an avionics bay, hydraulics, you name it.
So you can interact with it.
You can fully interact with it. The training modules use these twins for really intensive hands-on practice. Things like digital twin engine maintenance, diagnosing tricky faults. They also cover really specialized stuff like repairing composite materials or handling stealth coatings, which are super sensitive.
Right, you can't exactly practice applying stealth coating on a real F-35 wing repeatedly.
Not easily, no. And even high-risk procedures like weapon system loading and arming, you can drill those safety protocols until they are absolutely second nature with zero actual risk.
Okay, the value proposition there seems really clear. That ability for unlimited safe practice. Let's go back to that engine turbine fault example. In the real world, diagnosing a rare fault like that could ground a plane, cost a fortune. How tangible is the return on investment here? Are companies seeing savings quickly?
The sources point to a near immediate ROI, mostly through reducing that AOG risk we talked about.
Okay.
Imagine you've got new technicians. They need to get up to speed fast on a specific rare issue on a critical aircraft. Traditionally, you might need to pull an operational plane or use very expensive mock-ups. It's slow, costly.
Right.
With a digital twin and XR, that technician can run through the diagnosis sequence maybe 100 times, 200 times in a safe virtual space.
Wow.
They build confidence, make mistakes safely, learn faster. You're potentially compressing months of on-the-job learning into just weeks. It's shifting training from reactive fixing to proactive mastery.
That's powerful for efficiency. But efficiency alone doesn't fix the brain drain problem you mentioned earlier, which leads us nicely into the next big area: knowledge capture and preservation. How does XR tackle that?
Yeah, this is huge. Losing that expert with 30 years of avionics experience. You're not just losing a person, you're losing their unique troubleshooting instincts. The sources call it expert diagnostic heuristics, those intuitive leaps, the know-how that's not in the manual. Preserving that is vital for continuity.
It sounds almost impossible to capture, though. How do you digitize intuition?
It uses AI-powered knowledge capture. Essentially, you have the expert perform their tasks within the XR environment.
Okay, so they're wearing the headset, doing the job virtually.
Exactly.
Yeah.
And the system records everything. Their exact movements, the tools they choose, their decision points, even their voice explaining why they're doing what they're doing.
Huh. So it captures the how and the why.
Right. It turns that individual tacit knowledge into a digital asset for the whole organization. And this feeds directly into creating new training. There's an interactive knowledge vault authoring system. So organizations can quickly build custom modules based on what their own top experts just demonstrated.
So the expert's actions become the template for the next generation.
Precisely. And think about mentorship. A retiring expert could literally hold virtual sessions in a virtual hangar, guiding trainees through complex repairs on a digital twin even after they've officially left.
That's incredible. It bridges the gap and also addresses the compliance side, I imagine, if everything was recorded.
Well, absolutely. That's a critical compliance angle. The platform generates verifiable competency records. When a trainee masters a task in XR, the system creates this immutable audit trail, proof of competency.
Which is gold for FAA or DoD audits.
Pure gold. It shows demonstrable proof they've mastered the required standard. Massive headache relief for compliance officers.
So the big picture here is digitizing institutional memory, making it scalable. That expert knowledge isn't lost. It's available to everyone, everywhere, instantly. Future-proofing expertise.
Okay, let's shift gears now. We've covered maintenance, knowledge capture. What about the operational side? Group C in the sources, operator mission readiness. Training for those really extreme scenarios. Right, the situations that are just too dangerous, too expensive, or frankly, too rare to ever practice live. XR makes them trainable.
Give us some examples.
For pilots, think about catastrophic failures like a dual-engine flameout simulation or rapid decompression. You absolutely cannot practice that safely in a real aircraft.
No way.
But in a virtual cockpit, they can drill those emergency procedures over and over until the response is automatic. And it goes beyond aviation. Think space. Astronauts training for space systems anomaly response.
Like what kind of anomalies?
Things like dealing with a sudden critical solar flare event or performing an emergency repair on the exterior of the ISS. These are incredibly high-stakes, low-frequency events you can't replicate on Earth.
Makes sense. And what about ground and sea forces?
Similar applications. For the Navy, shipboard damage control, training to fight fires or patch hull breaches under simulated combat conditions. You obviously can't set your own ship on fire for practice.
Obviously not.
Or for armored vehicle crews, mastering complex tank crew combat systems. And increasingly important, drone or UAV operator training, practicing complex surveillance or engagement scenarios without risking expensive assets or revealing tactics.
It sounds incredibly powerful across the board. Unlimited, safe practice for the worst-case scenarios. What's holding back wider adoption then? Is it just the cost or maybe cultural resistance in these, very traditional organizations?
It's a mix. Historically, a hurdle was creating those super accurate, often classified digital twins. That takes effort.
I bet.
But the hardware costs, they're plummeting. And the resistance, well, it's melting away as the performance data becomes undeniable. When you show how this reduces risk, improves readiness, and ultimately saves money compared to even one major incident,
The math starts looking pretty good.
the math becomes very compelling, very quickly.
Okay, that operational readiness piece is vital. But it relies on a solid foundation, which brings us to the last group, Group D, the defense supply chain and industrial base. Compliance and resilience there seem just as critical.
Absolutely critical. This is a huge area, especially with the DoD's intense focus on supply chain security and integrity. The training has to embed that rigor from the factory floor up. We're talking secure manufacturing practices, especially under ITAR regulations.
ITAR, that's the International Traffic in Arms Regulations, right? Super strict rules about defense tech.
Exactly. Very strict controls on exporting defense items and technical data. XR training helps ensure everyone, from the engineer to the machinist, handles that data and those components correctly, securely. It builds compliance into the workflow.
Okay, so physical security and data handling. What about cyber? That's huge now.
Massive. The platform includes training for defense industrial-based cybersecurity. It focuses heavily on meeting standards like CMMC.
The Cybersecurity Maturity Model Certification?
Right. and NIST 800-171. These aren't optional if you want to work with the DoD. XR can simulate cyber attacks, phishing attempts, data breaches, training staff, how to respond and maintain security under pressure.
So it tests their resilience in a safe environment, and I assume quality assurance is baked in too.
Definitely. Quality assurance for aerospace components, often tied to the AS9100 standard. For listeners, this isn't just general QA. AS9100 demands absolute traceability for every single part, every material, every process. The stakes are just too high.
So a parts supplier could use XR to basically run mock AS9100 audits on themselves.
Precisely. They can rehearse the entire audit process, find gaps, fix them, and ensure they're fully compliant before the real inspectors show up. It turns a potentially stressful compliance hurdle into just another mastered process.
Okay, so if we pull all this together, MRO, knowledge capture, mission readiness, supply chain, it really feels like a complete transformation of how this sector prepares its workforce.
It really is a paradigm shift. Let's just quickly summarize the before and after. Before XR, training was often limited by cost, by danger, by access to real equipment. Now, you get unlimited safe practice on perfect digital copies.
Right. And before, vital knowledge walked out the door with retirees. Now, AI captures and preserves that expertise, making it a permanent company asset.
Exactly. Before, those extreme rare emergencies, maybe you talked about them, but you couldn't really practice them. Now, XR makes the impossible trainable, building real muscle memory.
And compliance used to be maybe inconsistent, lots of paperwork. Now, standards like ITAR, CMMC, AS9100 are embedded right in the training, linked directly to verifiable proof of skill.
Yeah. The end goal here is simple. Build and maintain a mission-ready workforce. It creates this clear path. Learn the skill, practice immersively, get certified, apply it on the job, achieve mission success. Zero gaps.
It feels less like just improving training and more like fundamentally re-engineering the pipeline for talent and readiness in sectors where, as you said, there's zero margin for error.
That's exactly it. It's about ensuring security, capability, safety. It's providing the tools to build the workforce needed to meet that incredibly high zero-error standard and do it globally, scalably.
It really is about future-proofing these critical industries, especially given that talent crunch we started with. The power to take something incredibly complex, high-risk, super specialized, and make that knowledge instantly accessible and scalable worldwide, that's pretty profound.
And it leaves us with a really interesting question to ponder, doesn't it? If XR can perfectly simulate training for, say, deep space emergencies and capture the deepest knowledge of retiring experts, does this mean that the whole idea of critical operational knowledge being truly lost forever, is that concept about to become obsolete?